for the unit circle. I'm going to draw it out, but I have to say it's important to convert between degrees and radians in order to understand the unit circle. So I'm gonna go ahead and keep going. So here I drew out a sketch, and it starts at 0 right here. So 0 radians, or 0 degrees if you want. So this is 0 degrees, this is 90 degrees, 180 degrees, 270 degrees, and 360 degrees, which is back to 0. So I'm going to switch to radians. In order to work with radians, I have to know that you can, so that you have to know that it's degrees divided by 180 times pi. So I'm going to start with this point here. This is 30 degrees, 30 degrees, 60 degrees, 90 degrees, and so on. So for 30 degrees, all I have to do is take 30, divide by 180, multiplied by pi, and you get pi over 6. So that means that this spot right here is pi over 6. And then this would be 45 degrees. In order to get 45 degrees, I take 45, divide by 180, multiply by pi. I get pi over 4. This would be 30 degrees, which is the same as pi over 3. This is 90 degrees, which is the same as pi over 2. And from there you can pretty much guess everything else without really converting anything. So this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and 4 pi over 6 simplifies to 2 pi over 3. This is pi over 4, pi over 2, 3 pi over 4, because we're going 1, 2, 3, so 3 pi over 4. And this is 5 pi over 6, because we have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6 pi over 6 is pi. And then we have 7 pi over 6. And here we switch back to the pi over 4, so we have 1, 2, 3, 4, 5 pi over 4. And over here we switch back to pi over 6's. This was 7 pi over 6, so from here to here is 8 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. And from 8 pi over 6 to 9 pi over 6, which simplifies to 3 pi over 2. You can confirm this by counting by pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2. Okay. And then this would be, if this was 9 pi over 6, let me make sure, this was 7 pi over 6, 8 pi over 6, 9 pi over 6, that means it's 10 pi over 6, which simplifies to 5 pi over 3. And then 11 pi over 6. And then 12 pi over 6 is 2 pi, which is 0. Now this one, if we switch back to pi over 4s, we have 1, 2, 3, 4, 5, 6 pi over 4, 7 pi over 4. So now we have the complete unit circle. So the coordinates of the unit circle are kind of tricky, so let's see. I'm going to draw the triangle for pi over 6. The hypotenuse of this triangle is equal to the radius of the circle, and the radius of the circle is 1. The radius of the circle is always 1. So if you see this line right here, this line is the radius, it's equal to 1. This line is the radius, equal to 1, so on. So for this triangle, I basically drew the height, and I have the width right here. So the height is the y value. For this point, we have this point located at pi over 6 degrees. So if we imagine that we are revolving around this unit circle, we so far have gone, sorry, did I say pi over 6 degrees? I meant pi over 6 radians. We're not in degrees anymore. So we're going around the circle. So we've so far reached pi over 6 radians. So this is the point that we are at. So we're going to find the coordinates of that point by getting the y coordinate and the x coordinate. So we see that we can find these by using what we know about our triangles. So pi over 6 is the same as 30 degrees because that's what we converted. So since we are here at 30 degrees, we know that our x, to find our x, it is the same as cosine because cosine of pi over 6 is x over 1, or just x. So cosine of pi over 6 is the same as cosine of 30 degrees, and we know that cosine of 30 degrees is root 3 over 2. And to find our y, we can use sine of pi over 6 because sine of pi over 6 is opposite over the hypotenuse, which is just y over 1, which is equal to y. So that means that our y value is the same as sine of pi over 6, which is 1/2. So for the unit circle, a basic rule is that the coordinate xy is always going to be cosine of your theta, comma, sine of your theta. So let me write that down. So we have x, our coordinate is always cosine theta, comma, sine theta because of the fact that the radius is always 1. So we have x over 1, which is cosine theta, and we have y over 1, which is sine theta. And that's how we get the coordinates. So I'm going to fill in the rest of the circle. So the coordinates for this point on the circle is root 2 over 2 comma root 2 over 2 because of the fact that this length is 1 and we're dealing with the 45, 45, 90 triangle. If you can see that in purple, where this is the y, and then this length here is the new x. And we're going to keep going for pi over 3, which is the same as 60 degrees. We have that the x value is cosine of 60 degrees, which is 1/2, and sine of 60 degrees, which is root 3 over 2. And for pi over 2, it's really easy because our x value is just 0 because there's no x value. And our y value is just 1 because that's the radius. Now here, we are in the negatives for x, because when you think about any coordinate plane, these are the positive x values and these are the negative x values. So we are in the negatives for x. So the x value here is going to be negative, and we are at 2 pi over 3 radians. So if we continue to think about the 30, 60, 90 triangle, we will see that, okay, let me go ahead and draw that triangle. This is 1. If we think about the 30, 60, 90 triangle, we will see that this angle right here looks a lot like 60 degrees. Well, this angle is pretty much 60 degrees if we just look at the triangle. So that means that the x is 1/2 and the y is root 3 over 2. And just to remind you what that looks like, I'm going to take you back to the triangle we drew down here where we have 1, 60 degrees, 30 degrees. We have 1/2 for this length, root 3 over 2. Okay, we're going to keep going. And we're back to the 45, 45, 90 triangle. So this is root 2 over 2, comma, root 2 over 2. And for 5 pi over 6, this one this triangle looks a lot like this triangle that we drew right here, so it's going to have very similar coordinates. Whoops, I forgot to put the negative. So that's negative. The x value is negative, and this x value is negative because we're obviously on the negative side of the coordinate plane. So the x here will be negative root 3 over 2, and the y, since we're still on the positive y coordinate, is going to be 1/2. And then for pi, it's really easy because the x is just the length of the radius of the unit circle, so that's 1, and then there's no y value, so it's going to be 0. And we can keep going around just switching back and forth between our 30, 60, 90 triangle and our 45, 45, 90 triangle. Negative root 2 over 2, comma negative root 2 over 2. Negative 1/2, comma negative root 3 over 2. This is 0, comma negative 1. This one is going to be, now we're in the positive x, but we're in the negative y, so the positive x, positive 1/2, negative root 3 over 2. This one is going to be positive root 2 over 2, negative root 2 over 2. This one is going to be positive root 3 over 2, negative 1/2. And then we're back at 0, and the coordinates for this is just 1, comma 0. Sorry, the coordinates for pi is negative 1, comma 0, because we're in the negatives. So as you can see, as we go around the circle, we have our x getting smaller and smaller and our y getting bigger until we have 0, comma 1, and then as we go the other way, we have the x's getting more and more negative and the y's slowly decreasing to 0, and then we have the x's going from negative 1 to 0, and we have the y slowly decreasing from 0 to negative 1, and then here we have the x's slowly increasing, and then we have the y also increasing till we get back to our starting point.